All right, thanks for watching this video. Astro Helper is it's an astrophotography planning session tool that I've been working on because I've found that a lot of the tools out there like Telescopius and Stellarium don't do a great job of incorporating complex horizon boundaries. And one of the things that I struggle with is that in my yard I have some trees that are at almost 70 degrees altitude, and there's just a lot of variation. And so when you're trying to figure out when a target is going to become visible and when it's going to disappear, it can get a little tricky. So what I wanted to do was essentially incorporate a lot of the things you would expect from a planning session tool, but also add the ability to upload a panoramic photo of your site and outline those boundaries. And that way it can accurately predict the rise and set times and the integration windows, you know, how long you have to image, which of course is really important. And of course, it does a lot of the other things you would expect as far as what it looks like, including your equipment, the field of view, what kind of filter you have, the moon brightness that night and its impact based on when it rises and sets on broadband targets, for example. So that's kind of what the point of this is. And once you get your locations and equipment set up, this information is persisted. It's saved locally in your browser, so it's not sharing that data with the application or myself. And you can just quickly go back up here every day and get a list of viable targets. So I'm going to go through how to set this up here. The first thing you're going to do is add a location. You can have multiple locations. I'm not going to put in my real address, but you can certainly use my current location, which will bring up a security thing asking if it's okay to share it, and you can get it specifically that way, or enter the coordinates manually if you know what your lat long is. Just for purposes of this demo, I'm just going to type in Virginia Beach, and it's just pulling a generic latitude and longitude here. This is probably at the ocean front. And it does look up the Bortle class or light pollution score for the location that you entered. Those are based on some maps that I have locally in the application. You can override that value though if you know better for your location. But I generally should be around 6.1 here for this location, which isn't super great. All right, so once you add that location, you can get that photo in so we can get that correct horizon, because obviously, well, you'll see here in a moment. So I'm going to choose a photo. You want to use a 360-degree panoramic photo. I can recommend Teleport 360. It's available on iOS and Android. Doesn't cost very much to just register it for a day and go in and take your photo. When you do take the photo, ensure that you make a note of the compass direction, of some compass direction. You'll understand why that's important here. So I'm going to go and pick this photo, which happens to be backyard here. So you'll notice right off the bat that I have a real problem with a high tree line here between the south and the west. And so as targets come up this way, they can appear and then disappear and then appear again, depending on what it is we're tracking. So the first thing you're going to do is set that compass reference point. So we're just going to tap here, and then I need to pick a spot where I know what the compass direction is. And I happen to know that right here, I'm going to click here, is east. And so you'll see that the compass labels shift appropriately. The next step is you just want to set, you're going to drag this line to where the horizon line actually is. So in my case, I know for a fact it's right here. But basically, this should be where the horizon actually is in your photo. It's hard to see in this photo because I have so much stuff in the way. Now, the next step is to actually draw your obstruction line. You can auto detect, it'll attempt to detect what the obstruction line is, but this is not super reliable. It's very easy to just draw it. So I'm going to just click on draw here. And you'll see I'm just kind of going over around these obstructions. And it doesn't, for my purposes anyway, doesn't have to be super accurate because I'm just trying to get an idea at what time I can bring the scope out and whether there are any broken visibility windows. So I'm going to go ahead and finish this. And you can see I have my obstruction line here. When you complete that, it generates this profile, and this shows you exactly where this revised horizon line is. So again, you know, from south to actually a good chunk of the south, southwest, west, northwest is almost up to 70 degrees, which is, you know, that's pretty big. If you are on mobile or you want to get a little bit more accurate, you can also zoom in to specific compass points here. And then you can go in and draw and be a little bit more specific about your lines here. But this should be more than adequate. And so I'm going to go down here and save this horizon photo. And you'll notice that it generates just this kind of cheat sheet just so you can kind of get an idea what this obstruction line looks like for that location. Now I can also add a second location, which I will do. And for this one, I am actually not going to add a horizon photo. This is a darker sky area that's slightly north of here in Virginia. And you'll notice I didn't add a horizon photo, so we're just going to use this. Now, there's a separate setting which we'll see in a moment for our session where we can specify what the minimal altitude is. Typically, you don't want to go below 20 degrees because you get atmospheric distortion. So, and that's the default, but we'll get to that in a moment. So we have our location set up. And so I'm going to go ahead and continue to our equipment setup. Now I have my primary rig is a Red Cat 51 with a duo camera and then a filter as well. Now there's a main setting here. If you happen to have a smart telescope, I do not have one, but I know they're popular. You can select that. You can select one in here and it will auto-populate this data for you. If you use a custom rig like I do, I may have your telescope and camera already in here. If so, you can just pick it. So in my case, I'm going to pick Red Cat 51. We have an aperture of 51, focal length 250, which is correct. And I'm going to go over to the 2600 MC Duo, which is what I'm using. And then for guiding, you can specify whether you have a separate guide scope or auto guider or whether it's sharing the main scope. So in this case, I use a Duo, which has a separate guide sensor built into the camera, but it shares the same glass as the telescope. And so if you put a filter in there, of course, it's going to reduce some of that light and it can make it a little harder for guiding. And so all this does is let Astro Helper know, and so it'll remind you that, hey, you may have a little tougher time guiding, so you may want to, you know, extend your exposure times or whatever. So I'm going to go ahead and select that. I do have a filter, and I'm just going to select dual here. It's a standard dual narrowband. Now, if you have something like a narrowband filter, when it scores results, as long as you have that filter available, it will give you a higher score for emission targets, which will benefit from that. So like I'm in a high light pollution area, unfortunately, and so I really need a narrowband filter for those emission targets. But it also makes broadband targets not as good, and that's all reflected in the scoring when it evaluates. So I'm going to save this equipment profile. Now that's in there. You can also have multiple equipment profiles in here as well. So if you want to set up multiple on the results screen, you'll be able to quickly change between them, so you can get an idea of like maybe which one is a better fit for the night's observations. All right, so last step here is session setup, and you're going to pick your date. You can go far in the future if you want, but weather obviously is not going to be accurate, and the application will tell you that. But it still can be useful for planning. Right now we're in a period of full moon, and so there's a lot of moon brightness, which makes some targets not a good idea right now. But I can look further out and look for a time where that isn't an issue. So, but for demonstration purposes, I'm just going to select tonight. And right now it's using our last set location of Cape Charles. I'm actually going to change that and set backyard to active. Go back to session setup. And here's our minimal usable altitude. So again, I typically should be around 20 degrees, but if you want to adjust that higher or lower, you can certainly do that. And so when we continue to results, we're going to get everything returned back to us. And this information is persisted. Your equipment, your locations, all of that. So once you set those up, you can just come back to Astro Helper each day and click on change your session date and click on results and get the same results back. So here at the top, I can quickly change to other equipment or locations if I want to get an idea of how those impact the results. These two cards here are focused on weather, and this bottom area is where all of your recommended objects are. And the first thing I should point out is that weather and atmosphere do not impact the recommendations. It's meant to be a separate thing. So the first gate is it even worthwhile going out tonight? And it's going to look at all of these things, including cloud cover and wind, and it will actually call out anything that it thinks you need to know about. So, this is August, East Coast, so dew is definitely a consideration. Low wind gusts, so I don't need to worry about necessarily anchoring down the tripod. And then transparency and seeing, which basically, if you have a high turbulent atmosphere, which it will detect, then you might want to stay away from planetary or high magnification viewing, and it will warn you of that. So here's our weather stuff here, but I'm really going to focus on the recommended objects. So it's already warning me right off the bat that this is kind of a high Bortle. There's a lot of light pollution here, and yes, I know that, unfortunately. Also, there's a bright moon out, and so that's also going to make hitting broadband targets particularly bad. So I can already tell you I'm going to be avoiding any kind of broadband targets, and it scores appropriately. You'll notice most of the recommended objects here are narrowband targets. So these are things like nebulas that where we can use a filter and block out the common sources of light pollution without losing that critical light that we need. So scoring is basically, they start off at 100 and it just starts subtracting based on all of this information, the equipment that you're using, the amount of time that it's available. So you can see here, it tells you like the Maya Nebula is visible from 235 to 455, and it's taking into account getting over that obstruction zone. And so we have our scoring here. We have any notes. It's reminding me about my guide center. It's warning me that, hey, the moon is 91% illuminated, and it's going to be during part of that visibility window. It doesn't subtract as high of a score because I have a filter available, which can filter out a lot of that light. So the other thing is this here gives you, based on the equipment that you put in, basically it's going to show you how much. So this green box is essentially the image that we're going to get out of the scope camera combination. So we can have an idea of like what the apparent size is. You know, I typically want, and it will actually score things lower that don't have a good size. So you can see here blue, that means that it's not as big in the frame, and it's even telling you, you know, may say up here that it's 0.3 the moon's width, which is pretty small. And you may even have some that score worse, like this one here. So the other thing is, just to show you, now we're getting into really bad stuff here. These are all fair. I wouldn't even entertain these. You'll notice the planets are also included here, but this particular scope combination doesn't have the right focal ratio for planets. You need something with different focal ratio. So essentially it's saying that's not a good, and that's correct. So I know that that's correct. But if you have another scope, you could add a second one and include that, and then pull that in if you're looking to do planetary viewing. Let's click on one of these targets here. We'll start with Flaming Star Nebula, just so you can see. When we click this image, give us an idea. Again, we're getting a zoomed in image of how big this would look with the final image that's produced, again based on the scope and the camera that we're using. And in addition to some details here and an About tab where you can find a little bit of information and even get a link to Wikipedia about it, there is also a framing tab. This is something I'm still working on, but essentially I can kind of get my framing on how I think I want to get this thing framed. I'm actually picking up a couple of nebula here because only one of these is the Flaming Star. And I can even adjust the rotation. And I can copy these values and use them somewhere else in my actual plate solving software, whether you're using the ASI Air or Nino or whatever you're using. And I still recommend using those tools. This is really about getting a quick, just a quick overview of what's good to see and when it's going to come out. The other powerful feature here is filters and sorting. So I can do a few things. So right off the bat, I know I only want narrowband targets. So I'm going to say, just show me those. And that's already limited this down to 38 out of 104 recommendations. And I really only want things that are good or better. I want at least 20%. I'll just say I want 20% of the minimum fill frame. And with astrophotography, of course, you want to get as long of integration time. In other words, how long you can take these images so you can stack them. And 4 hours is kind of what I would be shooting for tonight. And so it's really based on all this criteria. It's already said I got 6 for you to look at that meet all this criteria. And this is kind of what I would expect. The Heart and Soul Nebula are common targets this type of year. And again, I can go in here and you'll notice that it's focused on the Heart Nebula, but I can go into framing and adjust this framing so I can get both of these, which again is a common target. And I can share this information with my plate solving software when I go to do it. So right off the bat, I know, okay, these are some really good targets for me tonight. And that's really the primary focus of this application, is just to give you a quick rundown on some good targets based on everything. And I can see exactly when I bring the scope out. So if it's going to come over the tree line around 10:15, you know, I might start getting things set up, you know, a half hour before that or so. So it's really just very helpful for planning. And this does take into account darkness windows and all that. So 4:55 is the cutoff, more than likely, because that's when we're starting to get some of that sunrise light in the frame. So that is kind of it at a high level. If you have any suggestions, this is still a work in progress. Anything you'd like to see added, I would like to consider adding. For those just using, you know, optical, you know, with an eyepiece for normal observation, I would definitely consider doing that. You can technically use that. It's just that I'm not going to be taking into an account the eyepiece resolution and all that, but you could still set up your scope with that information for visual observation. And it does support a few different languages. If there's an additional language that would be helpful, let me know and I can work on getting that added as well. And again, this is all free to use. Once you set this up, now I can come back in here and I can go in and change my session for the next night. If I put in, let's put in September 14th and continue to results. So you'll notice it's not even going to tell me forecast information because it's just too far out. But I can get an idea though. You notice I'm getting much better scores now because there's no moon at that time. So very, very easy to just kind of go in and generate a new planning session each night without a lot of fuss. The information this does not use AI. It does not use any tokens. It's completely free to use. The information is stored locally in your browser. I'm going to just bring up the dev tools, and if you look here under storage, you'll see where it actually stores it. So this is all saved locally. It's not sent to the application. The only thing that really goes out to an external service is your coordinates, because I have to get the weather report for your location. But I'm not storing this again. So if you clear your cache or remove these, then you will lose that information and you'll have to add it again. That seemed like the best thing from a privacy perspective. If there's really interest in having a login or something where we can persist that and save it in a database, I'm certainly happy to do that. And that's about it. If you have any comments or suggestions, you can add them either to this YouTube video. I'll look at them, or you can shoot me an email and I'll be happy to take a look.